Good morning, everyone. So we are here and making this lecture video for your second topic. Last meeting, we talked about force and different types of forces, non-contact and contact forces. This time, we'll have another topic very related to force. Now, this is my question for you. Have you seen Despicable Me 1? Anybody? I think most of us already seen this movie. It is a really nice movie. So I think you have seen this clip as well. Let me play it for you. I hope you can hear this. I hope you can hear
Hey,
this.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So his name, that villain,
Check
is
out my new
Vector,
weapon.
right? He describes
Piranagon!
himself as a
Oh,
mathematical thing or equation, not really, that is represented by an arrow with both magnitude, direction, and magnitude. So like direction and magnitude, and vector with both direction and magnitude. So basically, vector is mathematics. It's related to mathematics, but it's also related to science. Okay, take note, we're dealing with physics this quarter, so physics and mathematics, they're sisters. So that's vector. For you. So force is technically a vector because force is represented by an arrow, okay, with its direction, with its length and direction. So you have your length and direction where it is going to. So force is a vector. Remember that. Force is a vector. Vector is a quantity that has both direction and magnitude, right? So that's a vector. So vector, naa na siya kauban, so vector or scalar. So a quantity can either be vector or scalar. Scalar quantities are quantities with only magnitude. So it only has magnitude but no direction. So you can see here, okay, magnitude. But vector has both a magnitude and direction. It has the length, the measure, and also where its direction is. So let's try to identify which is which. So direction, take a look at the different quantities. Let's try to check their unit. Let's see whether it's scalar. Remember, scalar is only magnitude, no direction, whereas vector has both magnitude and direction. So mass, its unit is kilogram. Does it have direction? No. So it's scalar. Very good. Distance, does it have direction? No. So this is scalar as well. How about temperature? Temperature doesn't have direction, so it's only magnitude. So that's scalar as well. How about velocity? Meters per second north. Does it have direction? Yes, of course. So this is vector. So velocity is an example of a vector quantity. How about acceleration? You have meter per second squared, downward. So downward is this direction? Yes, of course. So downward is direction, so this is acceleration is a vector quantity. Volume, cubic meter. Does it have direction? No, that's scalar. How about speed? Yes, scalar. How about area? Correct, scalar. How about time? Scalar as well. How about electric current? Ampere. Scalar as well. How about force? Force's unit is Newton to the right. Always yun siya nga na siya to the right, to the left, north, east, south, west. The four cardinal direction. So force is absolutely a vector. So take a look at this. You have a table and a book on a table. So what are the forces acting on the book on top of the table? Yes, that's correct. You have your gravitational force as well as what else? Yes, that's normal force, or other name for normal force is support force. Now take a look at the direction. In which direction does the gravitational force going? Yes, that's downward. Whereas your normal force is upward. Basically, gravitational force always goes downward, whereas normal force always goes upward. Now, sa may ilahanan ma'am nga gravitational force ta. Now, remember that gravity is non-contact. Even though there's no contact, we're still experiencing, or we still is being subjected with force, gravitational force. So that's non-contact forces. So nga nung nakabalo matanga naman ni gravity, that's because we're not floating. If there's no gravity, then we're flying. We're basically floating. Now, ma'am, nga nung nakaingon man ka nga natin normal force. That's because if something's pulling us towards the center of the earth, then we should be in the center of the earth right now. But we're not, because there's support force that's preventing us from going further down due to gravity. So we are not floating because of gravity, and we're not falling further. That's because of support force. And what do you think are the forces acting on yourself right now while watching my video, while listening? What do you think? You're sitting down, laying down, watching YouTube? Yes, basically, since you're at rest, you're just sitting down there, you have gravitational force. And since you're not falling further, you also have your normal force. Okay, so yeah, take a look at this example. So dog running fast. What are the forces acting on that dog? First, since a dog is not floating, it's staying still on the ground, it's has gravity, it's not floating. Second, always yun na siya, gravity and normal forces there. Second, if your object is on top of things, like on top of the table, on top of the ground, it's not hanging, because we have a different force acting on if an object is hanging or falling down. But it's on the ground, on top of something, then there's normal force. So you have your gravity pulling it down, you have your normal force pushing the dog upward, preventing it from falling further. Also, since the dog is running, it's moving, there's an applied force for it to move. Now, why is the dog not slipping? Why is it na wala na siya nagatuwad-tuwad dara, na slip, na slide? That's because there's friction acting on the sole of the dog on the ground. Ano siya mana na niya. And di siya slip. If imagine this dog is, running on a very smooth, waxed floor, what do you think will happen? Right, slide, lisod yun na siya, dagan, paspas, slide. Just because there's less friction, preventing the dog from slipping. Okay, so I want you to do this task. Now, ma'am, saan man ipagbuhat, ma'am? I will be giving you a video. Still, I'll be putting the link here or in the description of this video, where you can watch a tutorial on how to do this graphing vector. You need a graphing paper for this, ruler, and pencil and ball pen. So for you'll be making a coordinate system. Coordinate system, just like in your mathematics, there's a coordinate system. Use pencil for coordinate system. And then for your vector line, this 10 units north, 5 units east, 7 units west, 15 units south, 20 units north. Use ball pen. Trace it with ball pen. So answer also these questions, 2 questions here, on the space on your graphing paper as well. Use only one graphing paper. So take note that 1 unit, so like 1 unit, 1 box. So you should have 10 boxes, but the lines should be, your label or your measurement should be on the line, not on in between the box. Okay, so just to watch my tutorial, I'll be adding the link here on this video. So that's your task for today, and we'll be checking your output when we come back. So please work on this because you should know how to do this in preparation for next week na activity or task nga kung ihatag ninyo. Okay? Okay, so that will be all. Thank you. Goodbye. See you next week. Bye.